This entire section might be review as well, so maybe you don't even need to watch the videos, but let me just jump into it. So in this section, we're mostly talking about interpreting graphs in terms of what direction they're going as we move from left to right. So a graph or a graph of a function is considered increasing over an open interval, which means an interval with only round parentheses, provided the y-coordinates of the interval get larger as you move from left to right. Or equivalently, the graph gets higher as it moves from left to right. I have two graphs written at the bottom of the page that I must have lifted from Google Images, and I point little arrows to increasing intervals. So if this graph that I have drawn here, I'm going to split it into three regions. A left region, a middle region, so this is going to be the left region of the graph, and then this is going to be the middle, and this is going to be the right region. I would say in the left region of the graph is increasing because if I'm drawing on this, my marker is getting higher as I move from left to right. So this is an example of an increasing interval because the graph gets higher as it moves from left to right. Also, the right interval is another example of an increasing interval because as I move from left to right and trace along this, my graph is getting higher. So this graph has two increasing intervals. The second graph, if I'm going to divide it into regions, I'm probably only going to make two regions. I'm going to make a left region and a right region. And in the left region, the graph is increasing because as I'm tracing along this graph, my marker is going higher as I move from left to right. That's what I need for an interval or a region of a graph to be increasing. If I'm just tracing along on it with my pencil, if my marker or pencil is going higher, the graph is increasing in that interval. And then a graph is decreasing over an open interval, which means an interval with only round parentheses, provided the y-coordinates are getting smaller. That's harder to see. This is easier to see. Or equivalently, the graph gets lower as you move from left to right. So in this first graph where I draw a left region, a middle region, and a right region, the middle region is the decreasing region because as I'm drawing on this graph, my marker is getting lower as I go from left to right. The second graph, the second or the right interval is considered a decreasing interval because as I'm drawing on it, my marker is getting lower. So this is super important just to be able to look at a graph and break it up into the regions where the graph is increasing and where the graph is decreasing. It's more important in terms of points on the test to be able to describe these regions in terms of x's. So how do I describe the intervals where a graph is increasing and the intervals where a graph is decreasing? That's a big deal here. So in the bottom left graph here, it's increasing in the left and the middle panel, and the graph is decreasing. So the graph is increasing in the left, the far left, and the far right region of the graph. It's decreasing in the middle. How do I describe, for points where it's decreasing? Kind of easy to do. What I'm going to do is extend my x-axis to the far left edge, which has a negative infinity. Extend the right x-axis to the far right edge, which has a positive infinity. And then along my x-axis, where the graph changes from increasing to decreasing or from decreasing to increasing, I'm going to write those numbers, the x-coordinates of those points down. The first place where my graph changes directions from increasing to decreasing, the x-coordinate of the point where it changes directions is -2. After a bit, my graph changes from decreasing to increasing, and the x-coordinate of that point is 2. I'm going to describe the left panel, the left region, as the interval round parentheses negative infinity, round parentheses negative 2. That's a region where this graph is increasing. The middle region, I'm going to go from the place where it changes directions, which has an x-coordinate of negative 2, the first place where the graph changes from increasing to decreasing, to the point here where the graph changes from decreasing to increasing, which has an x-coordinate of 2. I'm going to describe this middle panel in terms of the x's that represent the points that start and end this panel, which are negative 2 and 2. I'm going to say this graph decreases from negative 2 to positive 2. And the way it's worded, this wording here is more sophisticated math. This just means it wants round parentheses, because right at the place where it turns from increasing to decreasing, or it turns from decreasing to increasing, it's not going up or not going down, it's kind of paused there. The third interval I'm going to describe as 2 to infinity, the x-coordinate of the turning point to the x-coordinate of the far right edge of the x-axis, and that's an increasing interval, so I'm going to put it in my 2 to infinity. And just like when we're doing domains with intervals, we usually separate multiple intervals with union symbols. Just had to focus this, I wasn't digging the focus. This graph right here with A's, B's, and C's, not so good, but this right here looks like an x-axis. I don't know that that's a y-axis, but the far left edge of the x-axis has a negative infinity. The far right edge of the x-axis has a positive infinity. I don't know the point that this is, but it looks like it goes through B for its x. So I'm going to say, oh, this is the x-axis down here, duh. This is my x-axis here. Didn't even pay attention. So this point right here is the point B comma, I don't care, f of B. But anyways, the x-coordinate of that point is B. So I'm going to separate this graph in a left panel and a right panel. The left panel, the graph is increasing. The right panel, the graph is decreasing. For this second graph, if I wanted to describe the interval where this graph is increasing, it's going to be the left panel. The left panel starts at the far left edge of the x-axis, which is x equals negative infinity, and the x-coordinate where the left panel ends has an x-coordinate of b. So it's going to be increasing from negative infinity to b. I'm reading from left to right. And then for the decreasing interval, which is the second interval, it starts decreasing at b, it goes all the way off to infinity. So that's one of the big concepts that we're going to need in this section. If I give you a graph, you need to be able to identify, in terms of intervals, where a graph is increasing and where a graph is decreasing, all with round parentheses, all with only x values. The other concepts are I think, a lot easier. So a point is called a local maximum point, provided it's higher than any point close to it. Technically, a point is a local maximum point if at that point a graph changes from increasing to decreasing, but not such a big deal here. In the first graph that I drew, this point -2, +16, it's higher than any point around it. That's considered a local maximum point. So in this first graph, the local maximum point is the point -216. So it's kind of a cruddy graph to do this. I believe this is the point x equal to b, y equal to f of b. So this point looks like it's the point x equals b, y equals f of b. That's too complicated, but it's still a maximum point. It's higher than any place close to it. So the local maximum point in the second graph would be the point x equal to b, y equal to f of b. We won't have anything that complicated in the sections, but it's kind of nice to see some technical stuff. The next thing I wrote says the local maximum value is the y-coordinate of the maximum point. So this local maximum point of negative 216 has a corresponding local maximum value. And the local maximum value is y equal to 16. Usually, when you get in calculus, which you do this a lot, find maximums, local maximum points, local maximum values, we usually comment about the x. And I might say the local maximum value occurs when x equals negative 2. That way somebody can tell both the x and the y coordinate of the local maximum point. I'm not going to get into this. This function notation is a little bit too much to deal with here. But anyways, any point that's higher than a point, any point close to it's a local maximum point. The y-coordinate of that point is the local maximum value, which means that any point close to it, if you looked at any point close to it, maybe this is the point 112, which is kind of reasonably close to it. The reason we call this a maximum value is because its y is bigger than the y-coordinate of any point that's close to it. Last concepts on this screen, a local minimum point. A point is called a local minimum point provided it's lower than any point close to it. Technically, a point is a local minimum point if a graph changes from decreasing to increasing. Here, this point is lower than any point around it. It's a local minimum point. And it's right what happens. The graph decreases and then it increases. The graph changes from decreasing to increasing, so I get a local minimum point. So for the graph that we have on the left panel, the local minimum point is the point 2, negative 16. And the local minimum value is the y-coordinate of the minimum point, which means any point close to it, its y is going to be bigger than negative 16. And so for this, it would be appropriate to say the local minimum value is y equal to negative 16, which occurs, and I'll tack in the x here, when x equal to 2. Really, the local minimum value is just the y equals negative 16. This which occurs when x equal to 2, you almost always see that. If somebody's describing the lowest y value of a point, the lowest y coordinate of a point in a region, usually you tack on the x value. This is most of what's in this section. So let's jump into some problems and see what we can do. So for each of the problems between 1 and 10, I give you graphs. We need to find out where the graph is increasing, intervals with round parentheses, where the graph is decreasing, intervals with round parentheses, the coordinates of any local maximum point, the local maximum value, the coordinates of any local minimum point, and the local minimum value. How do I do that? I start off by breaking the graph into regions. There's a local maximum point of negative 2, 4. Let me just put that in right here. I can just tell by glancing that the point negative 2, positive 4 on my graph is higher than any point close to it. It's a local maximum point. And here the point 2, negative 4 is a local minimum point. It's lower than any point close to it. Now I'm going to create intervals to describe the increasing and decreasing. The first interval is going to go from the far left edge of the x-axis, which is x equal negative infinity, round parentheses, to the x-coordinate of this local maximum point, which is x equal to negative 2, also round parentheses. The middle interval is going to go from the x-coordinate of the maximum point, negative 2, to the x-coordinate of the minimum point, positive 2. And the far right interval goes from the x-coordinate of the minimum point 2 to the x-coordinate of the far right edge of the x-axis, which is infinity. These are my regions. I need to, for each region, describe whether it's increasing or decreasing. Now, if I just draw on the graph, I can tell. This first region, as I'm drawing on it, my marker is getting higher. So this is an example of an increasing interval. So part of my answer to the increasing interval is going to be the interval from negative infinity to -2. Once I get to that local maximum point, if I continue drawing through that middle region, in that middle region, as I'm drawing, my marker is getting lower as opposed to getting higher. Because my marker is getting closer to me as opposed to further away from me, that's considered a decreasing interval. So the interval from -2 to +2, all round brackets, is considered a decreasing interval. And then if I finish up my drawing, my marker is getting further away from me, it's getting higher on the sheet. This is an increasing interval for my third interval. So that interval from 2 to infinity is considered increasing. Usually, I put a U if there's multiple regions. So I've answered everything except the values, which are the y-coordinates. The local maximum value is the y-coordinate of the maximum point. So I'm going to say this. I'm going to say local maximum value, abbreviated, is y equal to 4, which occurs. How about local maximum value, MA, as opposed to just M? Otherwise, it could be minimum. I'm trying to abbreviate, but I'm being an idiot. So the local maximum value is y equal to 4, which occurs when x equals -2. And then for part F, the local minimum value is y equal to -4, which occurs when x equal to +2. It's everything. That's 6 questions, so it's probably 12 points on a test. Same questions for all the problems between 1 and 10. So for problem 4, I'm going to break it up into regions. First region is going to go from x equal -infinity to the x-coordinate of the local minimum point, which is -2, double round parentheses. I'm going to get a middle region, which goes from the x-coordinate of the local minimum point, which is -2, to the x-coordinate of the local maximum point, which is +2. And my third region goes from the x-coordinate of the local maximum point to the far right edge of the x-axis, which has a coordinate of infinity. Let me describe my increasing and decreasing. First interval, if I'm drawing on it, my marker is getting lower as I move from left to right. So this far left panel of the 3 panels is considered a decreasing panel. So that's going to be the region from -infinity to -2. The middle panel, if I'm tracing on it, my arrows are going up as I move from left to right. So that's an increasing region. And that would be the region from -2 to 2. The far right region, if I'm tracing on it, my marker is getting lower. That's an example of a decreasing region. So that 2 to infinity is going to go in my decreasing answer. Multiple intervals get separated with a union symbol. Now, the local maximum point is at 0.27. It's higher than any point close to it, which means the local maximum value is y equal to 7, which occurs when x equals to 2. A lot of times I skip the which occurs, and I just do this when x equal to 2. Rather than saying which occurs when x equal to 2, I just get the x in there, but get lazier in terms of what I write. The point -2, -1 is the local minimum value. It's the local minimum point, should I say. So my local minimum point is the point -2, -1. The the local minimum value is y equal to -1, which occurs when x equals -2. That's all there is to do for that. I'm going to have to estimate some points in number 6. I'm going to have to estimate this point, which looks like the point -1, -1. I'm going to have to estimate this point, which is going to be the point 0, 0. And I'm going to have to estimate this point, which looks like the point 1, -1. That's a local maximum point. These are both local minimum points. Since I have them, let me put them in here. So 0, 0 is a local maximum point. -1, -1, as well as 1, -1 are local minimum points. I put an and between. Probably could have put a union symbol between it. Probably would have been better, but it doesn't really matter. So let me separate this into panels. First panel goes from x equal -infinity to the x coordinate of this minimum point, which is -1. This first region is going to be in my decreasing, because as I'm drawing on it from left to right, my marker's going down. So one of the parts of my decreasing is going to be -infinity to -1. My middle panel, or my second panel, there's actually going to be 4, is going to go from the x coordinate of the minimum point, -1, to the x coordinate of the maximum point, 0. And this second of 4 regions, that's going to be an increasing region, because as I'm tracing, my marker is going higher. So in the region from -1 to 0, I'm going to put that in the increasing. My third of 4 panels is going to go from the x coordinate of the maximum point, 0, to the x coordinate of the minimum point, 1. And this is another decreasing interval, because as I'm tracing from left to right, my marker is getting lower. So that's going to go in my decreasing. I'll put a union between. The far right panel starts at the x coordinate of that minimum point, which is 1, goes to the far right edge of the x-axis, which has an x coordinate of infinity. That's clearly an increasing. I'm going to put that in my increasing, put a union between. Last things, I just need to answer the local maximum value. The local maximum value is y equal to 0, which occurs when x equal to 0. And this one's a little bit trickier, but not horrible. The local minimum value is y equal to -1. They both have y equal to -1, which occurs when x equals both positive and -1. So I'll put both x values there. I only get one split in 2 intervals in number 8, because there's just a minimum point, there's not a maximum point. As I glance at this, there's a local minimum point of -1, but there isn't a maximum point. There isn't like a hump up top, so there's none for local maximum point. There isn't a point, like that. So I'm going to separate this into 2 panels. First panel goes from the far left edge of the x-axis, which has an x coordinate of -infinity, to the x coordinate of that minimum point, which is -1. And this is a decreasing region. As I'm moving from left to right, my marker is getting lower. So in my decreasing, I do -infinity to -1. The second region starts at the x coordinate of the turning point, or the minimum point, which is -1, to the far right edge of the x-axis, which is positive infinity. And that's an increasing interval. So that interval from -1 to infinity is going to go in my increasing. Have everything I can get from the graph, except for these values. Since there's no maximum point, there's no local maximum value. And the local minimum value is y equal to 6, which occurs when x equals to -1. Split 10. There's a maximum point of negative 1, 3. There's no minimum point. Has two panels. The left panel goes from the far left edge of the x-axis at negative infinity to the x-coordinate of the maximum point, negative 1. That's an increasing interval. The second region goes from the x-coordinate of the maximum point to the far right edge of the x-axis, which is infinity, and that is a decreasing interval because my marker goes down as I'm drawing on it. Have everything answered that I could answer other than the D's and F's. For D, the local maximum value, I'm going to get even lazier. It's y equal to 3 when x equal to negative 1, and there is no local minimum point, so there's no local minimum value. One more concept, and it's an interval where a graph is constant. A graph is constant if it's not going up or down, and in problem 12, this middle interval drawn in red is a constant interval. So I want to describe where the graph is increasing, where the graph is decreasing, and now where the graph is constant, and then maximum and minimum points the best I can. I think 11 is a better problem because it kind of has something that's worth answering. So let's work through 11 together. I'm going to separate number 11. We'll notice that it has a hard start here at the point negative 5, 7. I'm going to separate it in the panels, but because the left edge doesn't go to infinity, I'm going to, instead of calling this panel negative infinity, I'm going to start this panel at negative 5. My graph on number 12, I would start at negative infinity, but the solid point here doesn't allow me to do that. So I'm going to go negative 5 to negative 2 for my first panel. That's clearly a decreasing panel. So first panel, negative 5 to negative 2, it's decreasing. And then my middle panel is going to go from the x-coordinate of that negative 2, 4 point to the x-coordinate of the 0, 4 point. This is the constant region where the graph is horizontal. This region right there from negative 2 to 0, we say is constant. Next panel is going to go from the x-coordinate of that point 0, 4, which is 0, to the x-coordinate of that minimum point, which is 2. And that's another decreasing interval. So in my decreasing intervals, I'm going to get 2. Negative 5 to negative 2 and 0 to 2. And then the last region goes from the x-coordinate of that minimum point 2 to infinity. And that's another increasing interval. It's the only increasing interval, actually. These points aren't maximum or minimum points because to be a minimum point, you have to be lower than every point close to you, and this point's on the same level, so this is not really a minimum point. Similarly, this really isn't a maximum point because there's points right next to it that are exactly on the same level. These are not minimums nor maximum points. This guy is higher than anything close to it. It's a maximum point. This point is lower than anything close to it. It's a minimum point. So my local maximum point is going to be the point negative 5, 7. My local minimum point is going to be 0, 2. But where the graph is constant, those aren't maximum or minimum points. The graph has to change directions to actually get one of the maximums or minimums. And then for the local minimum value or local maximum value, it's y equal to 7 when x equals to negative 5. And for the local minimum value, it's y equal to 2 when x equal to 0. Probably a good time to do a part 2. So we'll get to that in a second.